production.
Hey everyone, Alex Williams from the New Stack here for another episode of the New Stack Shorts. Today we are talking about TypeScript, the ever popular programming language. In particular, we're looking at the evolution of types themselves. This is all based upon an interview we recently did on the New Stack Bakers.
I'm joined today to talk about the future of TypeScript with Luke Hoban, who is the CTO of Bloomy and also one of the co-creators of TypeScript. Along with him, we have Daniel Rosenwasser, who is Senior Program Manager at Microsoft on the TypeScript team, and Brian Kavanaugh, who is a Principal Software Engineering Manager at Microsoft.
JavaScript became so popular, and then people started thinking, wait a second, I can move these applications that are on the desktop over to the web. Let's use JavaScript. But it didn't quite do it. And so they thought, how can we make this better? What about types? And that's when TypeScript came into the picture. Today, what we see is a new frontier beyond the browser, beyond just applications, and into worlds such as infrastructure cloud management.
How do we give folks the tools to do that when they're targeting the web platform? And by the web platform, that meant really JavaScript in the browser and all of the richness that was supporting. And that platform was growing incredibly quickly, right? The HTML standard was moving fast at that period of time. The ECMAScript, JavaScript standard was moving fast at that time. So this platform was getting very rich. A lot of really rich applications were built on it. The V8 engine and the Chakra engine were bringing performance to that platform. And so this tooling piece was sort of one big missing part of that.
But why types? Is it a security matter? We think about security all the time these days. It was really about data corruption.
TypeScript brings, from my perspective, on top of that is, a number of the sort of security issues you end up having, when you get past sort of buffer overruns and that sort of thing, which isn't really fundamentally kind of a problem in JavaScript. You then get to more sort of like logic errors that developers may make where they're not, correctly handling input data in a way which they need to have the right behavior for their components. And TypeScript, I think, fundamentally helps by bringing types, bringing static type checking. These are tools that fundamentally help developers to sort of create more correct code by default.
Without types, there could be inadvertent issues that arise. For example,
you can call parseInt and give it a number, and that number will be converted to a string and then back into a number. And you might think that that's a fine thing to do, but there are like hostile inputs that can show up here that will not round trip correctly.
But how do you even trust the types themselves?
There's an effort called trusted types where basically your server says to the client, hey, I want you to actually validate that anytime that you're about to put something into a slot in HTML, that needs to be a validated string in some capacity. TypeScript doesn't actually help in that capacity directly because that has to be runtime enforced. You need to basically make sure that you're not just arbitrarily putting a chunk of untrusted stuff onto the page. But TypeScript actually provides really solid tooling early if you're able to leverage that, right? So if you're able to say that, in each of these places on the page, I need to take a trusted string instead of an actual string. Well, TypeScript supplements the experience because the actual enforcement is in your browser, but you get a hint at when you're editing in your IDE or editor or whatever, with a little red squiggle saying, no, you're putting an arbitrary string here, but I need something that's actually validated before you do that. Security is not really the primary thing, but TypeScript does provide a better experience and, some guidelines to help guide you away from some of the pitfalls that you might encounter in JavaScript in that way.
Today, any number of services are built with TypeScript. Check out this perspective.
There's also this effort within Microsoft called Fluid Framework of trying to make it so that you can get something like Figma or the collaborative editing in Docs or Word or whatever. And that's written in TypeScript. And so that's a pretty cool use to see a lot of these newer ideas of opening up new paradigms for people and kind of lowering the barrier to entry is going to have TypeScript as a first-class citizen, and also those stacks will probably be written in TypeScript too, right? Just because of the complexity it requires in some cases. Google's got TypeScript as a first-class citizen now. I think most, if not all, new projects at Google are using TypeScript, Dropbox. Whenever I think about this list in my head, I'm like, who am I forgetting? There's someone I'm forgetting. There are too many people because it's who is not using the language?
And now comes the next frontier for TypeScript.
Yeehaw!
the realm of cloud infrastructure management, coming from the co-creator himself.
Languages, and in particular TypeScript, are really valuable for cloud infrastructure, where folks maybe used to be managing a handful of things, just like they used to be managing small scripts in the web browser. Now they're managing tens of thousands of resources. Those things are changing quickly. They've got real software complexity they've got to manage. And so bringing those languages into the infrastructure and cloud management space is increasingly important for organizations that want to sort of get the most value out of the cloud platform.
TypeScript is Turing complete. Types are like their own programming language. You can run small programs, and
we've enabled people to write recursive types in a way that that is optimized and allows you to go a little bit farther there, right? So you can actually do this thing where like you do go through all the letters of a string and parse it out in some cases. You know, we're not trying to go crazy with it. We're just trying to enable the right patterns where you're actually able to express what your JavaScript is doing at runtime. We don't want people to go overboard, but we're trying not to like get them stuck in some cases. There's this pretty cool feature of like tail call optimization that kind of landed in TypeScript that was sort of like a braggy feature. But it's a thing where like library authors can use it, and then everybody else sort of benefits from that.
But in the end, what about types in JavaScript? Wouldn't it be cool to just hit F5 to refresh the code? But then there's other matters you have to think about. What about bundlers? And what about how we view types themselves? That could take a lot of work. Our experts say there are really 3 or 4 ways to think about types in the browser. At the highest level is static verification. That really serves as a way to verify a type. Next down is a runtime checker, which can show exceptions instead of data corruption. And below that would be annotation, perhaps most popular of all, the ability to show comments that you can read in the source code.
The sort of annotations only model is the one that looks most likely to be successful. You know, it's easy to reason about like, is a string or number, but when you get into like much more complex types that TypeScript lets you write, having the runtime evaluate those questions in a consistent manner is a lot more difficult and not something that there's a lot of appetite for figuring out.
Hey, thanks for watching, everyone. Check out our podcast, The New Stack Makers, for the full interview with our TypeScript experts. If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.